Animal feed, on average, accounts for 75% of the total production cost. The various ingredients making up the animal's diet should be able to meet nutritional requirements. They should also provide support to the cells and microbial population in the gastrointestinal tract, promoting optimal function and aiding in immunomodulation, intestinal integrity, and mycotoxin absorption. The result is a maximum absorption and efficient digestion of nutrients, and consequently, higher profitability. Production animals are constantly exposed to agents that directly influence their health and performance. Other factors may raise animal production stress levels, as well as energy expenditure, and depress their immune response. Intestinal bacteria live in equilibrium and directly affect animals' health. However, stressor agents, such as environmental factors, pathogens, toxins, and chemical substances, can lead to an imbalance in this microbiota, which allows pathogens to proliferate further and cause inflammation that damages the intestinal epithelium. In this context, the mucosa, which is the intestine's initial natural barrier, has its permeability altered. As a result, the tight junctions in the epithelia become more fragile and eventually rupture, facilitating the invasion of pathogenic bacteria and toxic substances into the bloodstream, a scenario in which the outcome is reflected in a decrease of villi and alterations in digestion and nutrient absorption. With the market trending toward growth promoter and antibiotic withdrawal from animal production, this scenario is aggravated. The result is the growing importance of specific feed additives in controlling intestinal health. The immunowall production process starts with the harvest of sugarcane, followed by the grinding, pressing, and extraction of sugarcane juice. Part of the juice is fermented and centrifuged, resulting in a yeast cream that is divided into two portions, each of which is intended for a specific purpose. While one part of the cream returns to a new fermentation cycle, the other is separated and used as raw material for producing immunowall. The following steps involve proprietary fermentation cycles in bioreactors. These control aeration, temperature, pH, and other parameters, helping to facilitate an autolysis process, producing consistent results that guarantee the product's exceptional quality. To survive this harsh environment, the yeast cells develop cell walls many times denser than those from conventional yeast culture. A protective shield is born from an effective stress response. The result is the highest concentration of 1.3 and 1.6 beta-glucans and MOS, crucial ingredients to help win the battle for intestinal health. The increase in density of the yeast cell wall is responsible for the reduction in their digestibility. This increases their potential function when compared to common yeasts. MOS is one of the cell wall components and can bind or agglutinate pathogenic bacteria that have type 1 fimbriae. This includes strains of E. coli and Salmonella, preventing the colonization and proliferation of these populations in the intestine. Beta-glucans modulate the innate immune system, stimulating production and the activity of the phagocytic cells, which are the first line of defense and play an important role in the immune system. They can identify and destroy pathogenic microorganisms. These cells can recognize beta 1.3 and beta 1.6 bonds, and as a result, they release cytokines that trigger a chain reaction, inducing a higher immune status for animals, making them ready to fight opportunistic infections. Immunowall has the highest quality beta-glucans with a broad spectrum action. They interact with the polarity of mycotoxins through electrostatic forces. They also have an extensive surface area that maximizes mycotoxin adsorption compared with aluminosilicates. immunowall helps guarantee that animals maintain an intestinal microbiota balance. It also improves immune system response, resulting in the reduction of pathogenic bacteria contamination and transmission to other organs in the body. As a result, there is improvement in the animal's health and performance. Immunowall, hardcore yeast cell wall.